Hello, we did a lot today in Lesson 2's Launch, Explore, Discuss. First thing we did was look at these group of dots as they grew as a pattern. And the first question was really asking, how do you see them growing? Now, one way to think about it is that they're growing out from the center by adding one dot in each direction. So looking at them as 4 groups that are growing independently is one way to do it. Another way to do it is perhaps to see them as larger and larger squares with 4 corners that are being added together. That's really up to you, and it varies. But one of the things we need to do is count the dots. So we start with 1 dot, then we go to 5 dots, then we go to 9 dots. So in that way, we can predict the next figure. In other words, it stops at 2 minutes, as you can see here, 2 minutes. But what's the next one? Well, the next one is going to add 4 more dots. That's the pattern. We keep adding 4. So this mystery one over here, you could draw it if you like, has 13 dots. But then how can we express this going so far into the future that we can look at 100 minutes? Well, think about it this way. Every minute we're adding 4 dots. So we start at 1 dot, and then 1 minute passes, we have 4 more. Another minute passes, we have 4 more. And we just continue adding 4 over and over again to this pattern. Well, how many times would you add 4 in 100 minutes? It's the same thing as saying 4 times 100. You would add 400. Of course, you started with 1, so your total would be 401 after 100 minutes. So what about t minutes? Well, we're asked to analyze this in 3 ways, with a table, a graph, and an equation. Now, the table could be something like this. You could put time in one column and dots in the other column. So what number do we put at the beginning? Well, really no time has gone by, so that is time 0. There was 1 dot. Then at time 1, there was 5. At time 2, there was 9. At time 3, there was 13, etc. Well, what does that look like when we graph it? Well, using this graph, and you can use it as any way we want to. We can use the corners, so we could draw this as the x-axis. We could draw it a little bit farther in if you'd like. But here we have time horizontally and dots vertically. So the first row of our table, 0, 1, that could be here. 1, 5 would be here. 2, 9, over 2, up 9, here. And what you should start to notice is we're going in a straight line. In fact, the straight line, if you extend it, is predicting what the next number of dots is going to be. So what about the equation? Well, let's take one of these lines. Let's take this line apart. Let me write it out the long way. So at time is 3, we have 1 dot, and then we've added 4 dots. How many times? Well, after 3 minutes, we've added it in 3 times. This number of 4s matches this number here. So we've done 1 plus 4 3 times. Now, all we need to do to create an equation is use the letter t. And instead of writing 3, write t. So it's 1 plus 4t. There's our expression. Now, we're going to show you an official way to write a rule like this using something we call function notation. And it's later on in the lesson, it's actually right here. Let me break this down. This is a function, and it's named f. It's a very lazy way to name something. So the first letter you see, f, that's the name of the function. Then here is the input value. We're going to input t into it. And then over here, this is the rule of what do you do to t? You multiply it by 4 and you add 1. Let's see if that works with our pattern. So remember when we went out to 100, it was supposed to be 401. So we would write f of 100, in other words, input 100, and you get 4 times 100 plus 1. And that is 401. Now, when we write an equation this way, it's called the explicit equation, the direct way to write the equation. There are other ways to write the pattern, and one is called recursion or recursive thinking. This is where you think about how the pattern grows based on what you've already seen. So a recursive equation could be something like this. To get the next set of dots, you take the previous number of dots and you add 1 to it. Of course, you need to know where you start, and we did start with 1 dot. Start with 1. If you do this, and then you follow this rule, you can recreate the pattern. So you notice there's a lot of vocabulary in here today. Let's go through some of this. Under our takeaways, okay, we had ways to represent what's called an arithmetic sequence. Now I know that's the word arithmetic, but in this, when used this way, it's pronounced arithmetic. What is an arithmetic sequence? It is very simple. It's when you add the same number every time. In our case, we added 4 every time. We start with 1, and then you add 4, add 4, add 4, add 4. So here's another takeaway. You could say that multiplying is repeated adding. Just think about it. If the pattern is 1 plus 4 plus 4 plus 4, that's the same as 1 plus 4 times 3. 4 times 3 means you add 4 3 times. You notice there's some other vocabulary here. And we'll get to this when we can. One is a common difference. That was the 4 that we kept changing by. Function notation is when we write that f, the f of t. A function rule, that's what appears on the other side of the function's equal sign. An input-output pair is basically like this. When we said 0, 1, at time 0, there's one dot, and so on and so on. We will include these in our regular discussions as we proceed through the unit. But that's all for now. See you next time.